recording our Zoom, sharing my session. Good. And we're going to come over. I have 5 SQL fiddle tabs open here, one for each problem. And again, on the left plane, you have that schema. On the right plane over here, we have the problem. And here, the answer is 10 for this problem 1. If you go through over here on the left and just count all of the insert statements that are happening, there's 10 insert statements into the messages table. And so the answer is 10. Whether you put that in a table like it has down here, or just wrote the number 10, I don't care. As long as there's the number 10, then you get full credit. Any questions on problem number 1? Number 2. So now we're selecting from the users table, looking for username equals Biden, lowercase Biden. And if we come over here into our actual these things, then here we have Biden, uppercase Biden, not lowercase Biden. So it doesn't match, and we get a 0 as our count for number 2. Again, in SQL, the equals sign is going to be case sensitive. Anything inside the string that you're comparing to is case sensitive. But if we had changed this from an equal to a like operator, then it would be case insensitive. Any questions on problem 2? Number 3. There we go. So now we have a delete statement and a select statement. And here we're just deleting everything from messages where sender ID equals 4. And then we're finding everything in messages where sender ID equals 4. So there used to be stuff, I think, that this person sent, but now we've deleted it all. So there's definitely nothing. And so we get 0 down here. The answer for number 3 is 0. Any questions on number 3? Number 4. Come on, Zoom. Number 4. So now we're deleting this one's, I think, one of the harder ones. Deleting from users where username. We have the like operator, and we have the this double % sign. So we're looking anywhere where the letter A, again, case insensitive, looking for any, we match any user that contains the letter A over here. So if we look down, here's our users that got inserted. Well, Trump does not have the letter A. Biden does not have the letter A, so they stay. Evan, Isaac, Aaron all do have the letter A, so they'll get deleted. But then Mike and Kristen, no A, so they'll stay. So we get these 2 up here and these 2 down here for a total of 4 rows still in our table for problem number 4. Any questions on that? Number 5, last one. So now we have an update command setting the username to be Trump, where the username is like Trump. So changing just the value of this username right here. Again, we match whether it's lowercase or uppercase. And actually, yeah, here we go. So Trump used to be uppercase T, lowercase everything else, but now we have adjusted it to be uppercase everything with this command right here. And so we match one line exactly right there. Number 5 is a 1. Any questions on any of these problems? Great, go ahead and total your score out of 5. Make sure your name's on the paper and get the problems up to me. I don't need your schema sheet. You can do whatever you want with that. Just make sure I have the problems.
Hi, Senator.
You care about.
They're all in a funny order. Okay, again, today in class we have the notes up front that we're going to be going over in the topic 12 folder of our of our GitHub webpage, there's this new folder right here, practice quiz. And there's a lot of things inside of this practice quiz folder. A lot of things inside of this practice quiz folder. This dbcreate.py file is almost the same as the one that I had uploaded earlier, but I realized it had some slight differences. Well, yeah, so I've made some very minor adjustments to this. So recommend re-downloading this dbcreate.py file right here. And then all these other Python files are potential quiz problems for your last final quiz in this class. They're all going to be combining Python with SQL somehow. And the things that are printed out. So again, you're not allowed to use the electronic things during the quiz itself. So I've printed out a copy of each of these, like problem 1, 2, 3, 4, and 5 right here, so you can take some notes on it. The actual quiz, like the first problem on the quiz will follow exactly this format right here, just some slight modifications. And similarly, the second problem, exactly this format of this file right here, just some slight modifications, and we'll talk about what those possible variations are today. And all of these B versions over here, things that we're not going to explicitly talk about in class today, but you can use those to test your understanding of all the material that we'll talk about today. I'm going to be opening up in VS Code here all of those files, and we'll be running them in VS Code to see what they do. And on the quiz, you're going to have to tell me what is the output of these files. So if you would like to follow along running things, you're welcome to download these files and do that. Or I think the more important thing to do is just make sure you're taking notes on the handouts about what each of the parts of the code does, so that you'll have those notes on the quiz itself. Henry.
For the dbcreate, would we just replace the old one with the new one?
Yeah, the question is, for the dbcreate.py, can you just replace the old one with the new one? And the answer is yes. We're not going to use the old one anymore. The problem with the old one is that it was missing a line that was in the schema file. What this dbcreate is going to do is it's going to create a new database that exactly matches the schema file that we were working with. And it previously didn't exactly match the old schema, but now I think it hopefully does. Good question. Any other questions before we get started? Okay. Again, how this is. So all the material on these practice problems here are combining Python with SQL. How this fits into your final project and the labs is that you'll have to be combining those two things together in order to build your web page. So really the purpose of this quiz, the reason I think it's important is so that you know how to write this Python combined with SQL code for your final project. I'm switching over now to VS Code. And inside of VS Code, again, I have my practice quiz folder. I'm inside of my practice quiz folder over here. If I typed pwd, getting my working directory, you'd see that I'm in the practice quiz folder. And I've got all these different files over here. The one thing you'll notice right now, so pay close attention to this list of files on the left over here. All of these files currently are Python files ending in .py. The first thing I'm going to do is I'm going to run this dbcreate.py file. And there's lots of ways to do this. I could open it up and press the triangle button, but instead, I think this is easier for me, just to type out the thing down here, dbcreate.py, python3, dbcreate.py, and I hit enter. And if everything worked correctly, there will be no output at all to this program. No output at all to this program. But what you'll see now is over here on the left-hand side, where this list of files is, this new file was created down here. This twitterclone.db file was created down here. Before I ran this file didn't exist. Only the Python files existed. I'll go ahead and delete this again. Yes. So now it's only Python files here in my practice quiz folder. I'll press the up arrow, rerun the db create.py, and now it creates this Twitter clone.db file. Question?
And does it find that the file says it can't be displayed like when you click on it?
Question is, what happens when you click on this? The answer is VS Code cannot open this Twitter clone.db file. So how can we access the information inside this file? Last week, I asked you to download to your computer this SQLite 3 program like this. And SQLite 3 is a way that you can open up these DB files in order to run SQL commands on them and inspect what is inside of them. So SQLite 3 space, and then the name of the DB file, the database that you're trying to open, like that, hit enter. If everything works correctly, then we have a new prompt down here. We know we're inside SQLite now because it says SQLite and then this greater than sign. And now I can run any SQL commands that I might want to run. So something like select star from users, like that. And it tells me all of the information inside of the users table here. And again, this information is intended to match exactly the information on your quiz. If for whatever reason you were unable to get the SQLite executable to work, it's not the end of the world. It's not strictly required for anything in this class, but it does make debugging things easier because you can forget about having to combine Python and SQL for a little bit. If you want to know like what is the actual things inside of my database right now, you can always just open it up in SQLite and visually inspect it directly using these SQL commands. Select, we'll say how many messages, count star from messages, like that. So this is one of the quiz problems right here, and we get the number 10 like this. As you're working on your web page, though, people will be adding and deleting messages, and so these things will change. Again, the takeaway from this is that you run the, in order to get this Twitter clone.db file, so I'm going to delete it again. Come up here, the db create.py, run db create.py like that. It created the Twitter clone.db. And now if I wanted to run SQL commands on it directly, one way of doing that without involving Python is the SQLite 3 command, where you can run the database directly. One common error message that happens at this point is that, so here, notice that I've just run, oh, what happened? Get me my terminal back. Let's get back into the right folder here. And I'm just gonna delete this again and start over from scratch since that all got messed up. But if I, yeah, so I don't have my Twitter DB file right now. I don't have my Twitter clone.db file. I can rerun my db create file like this, and now it creates the Twitter clone.db file over here. If I already have this Twitter clone.db file and I try rerunning this db create again, then you'll see that I get this error message ending in this SQLite 3 operational error. What it's trying to do essentially is recreate all the information in the database, but that already exists, and so it gets this error. So if you're getting an error like this ever, it means you already have this Twitter clone.db file. Any questions so far? Okay, then what we're going to do next is take a look at this problem 1.py. This is again one of the handouts that you have, and we're going to walk through the code here so that you understand both how to figure out what's going on in code like this and how to create your own similar code. So the first thing up here on line 3, this is SQLite 3 is built into Python. So you don't need to install it. And anytime you're working with one of these databases, you'll have to do this import command. These two commands right here, this connection equals this, and then cursor equals this. These will be required whenever you're working with a SQLite database. You always have to have these two lines right here. Always need these two lines. What's inside of the string right here is the name of the database that you're planning on connecting to. Inside the string is the name of the database. For the purposes of the quiz, it's always going to be twitterclone.db that you're connecting to. And this twitterclone.db is always going to be the output of running Python 3 with the db create. So the database that you're connecting to is exactly the same database that you were working with on this last quiz. But these two lines right here, we would call them boilerplate lines because you just always have to have them. I guess this one too, all three of these lines, boilerplate lines. You just always start with this before you get to actually working with SQL. Down here, this next part's where it gets more interesting. The general pattern that you'll want to use when working with SQL is you'll create a variable named SQL that contains your SQL code. And so you'll see that this right here is SQL code that is just it's an ordinary string type in Python. Python has no knowledge that this is SQL code. It's just an ordinary string. And then the way this actually gets sent, the way this string gets sent to the database is this line 15 right here. You'll notice that this select statement, the purpose of a select statement was to extract information out of the database. And there is no like, I guess, there's no like information here being extracted. I'm not doing like something like results equals. There is no equals. Instead, the results are getting stored inside of this cursor. It's called a cursor object. And technical details about why that's working the way it is or what exactly is going on under the hood isn't important. But the important thing is cursor.fetchAll. Cursor.fetchAll gives you, so it's technically called an iterator in Python, but that's just, an iterator is something that you can for loop over. So it's basically a list. Of all the outputs. So the output here is not, it's actually computing it here, but the way you get access to it is this cursor.fetchAll. And anytime you have this cursor.fetchAll function, you'll put it inside of a for loop over every row that you get out as a result. And then the way you get access to the individual columns of that row is through the indexing operations. So row at position 0 will give me whatever is the 0 thing over here in my columns. So this will be my ID right here that I'm getting. Row at position 0 right here will get me the ID because ID comes in the 0 location right here. And then row at position 1 will get me the password over here because password comes in position 1. I'm going to go ahead and run this code now. So Python 3 and then problem1.py like this. And when I do so, you'll see that we got exactly one row returned. I know exactly one row got returned because these statements down here print out exactly once. And then it displays to us exactly what are the contents of that row. Well, the 0 column, again, that is the ID. The 0 column is the ID. That was equal to 1. And then the 1 column right here, the 1 column password, that is equal to Trump. And again, if you looked back at your SQL schema file, you would see that those those match the output of just running this SQL command directly on the SQL file without going through Python. So that's a quick overview of all the steps that you need to do to go through Python. Are there any questions about any of those steps, Jackson?
What if you wanted to do like either row 0 or row 1? What if you did row 0 and then bracket like 3 or something? You get like a specific ID. That work? Like row 0 and then it's basically like a list of a list. Or is that not how it works?
So you can think of cursor dot fetch all as a list of lists, something like that. Here, row though is going to be just a list. Think of row as just a list because you're looping over the list of lists. So each entry in this is going to be an individual list. So these down here, it only makes sense to have a single square bracket on.
So if I wanted to get like output of Mike, what would I want to type in that?
Question is, how do we get different output here? And the answer is that the output here, this code, you basically don't want to change. You'll always follow this pattern of for row in cursor.fetchAll, and then printing out or doing something with that row's information. If you want to get different information, what you do is you change what the SQL command is that you're running. So up here, I have select ID, password from users where username equals Trump. Let's change username to Mike, like that. Come down here, rerun this. And now we get the username and password for this particular user. If we change this so that we've seen something like username like %a%. So the username just contains the letter A somewhere inside of it. Then down here, rerun this. We get multiple rows returned now. This user ID 3, 4, and 5, and their corresponding passwords down here. So the way to think of this code down here is this is what you're doing with the information. And the way to think of this code up here is this is what the information is that you're getting.
So for like the first example,
Mm-hmm.
I don't know if you just think that like the user's name Trump all password. That's what return.
Let's see. So I'm going to go over to this dbcreate.py file here for a second. I think this might help us answer the question. This dbcreate.py file contains inside of it these sorts of things of doing the database connection. And then here's the SQL code creating the tables, running that SQL code right here. And then here's the data that's being inserted. And my hope was that this data was matching exactly the data that I gave you on the schema file, but is that not the case? Is this was capital Trump? Okay. Yeah, so this, at this point, I don't want to modify the dbcreate.py file, but this is going to be the gold standard of what to use for the quiz. And you'll have a printed out copy of the dbcreate.py file that you can look at to see what's going on. Good question, and I apologize for the slight differences. Henry?
Is there a way to iterate over the columns?
Question is there a way to iterate over the columns? And the answer is that you never want to do that. There's no way in SQLite for you to know that something, like what would be really nice, and I don't know why they didn't do this, but it would be really nice if you could do something like row at ID like this to get the ID value, and row at password to get the password value. It'd be really nice if this row was like treated like a dictionary somehow, but you can't do that in SQLite 3. And instead, this 0 and this 1, the only way that you know what like the semantic meaning of this 0 is because the ID up here comes in position 0. The only way that you know what the semantic meaning of this 1 is that password comes up here in position 1. If I were to change this in any way, doing something like password, comma, ID, and coming down here and rerunning it, you'll see that those rows, the columns have changed for this row. Now at position 0, we get Trump, and at position 1, we get 1. So it sort of semantically makes sense to loop over the rows like this, but it's never going to semantically make sense to loop over the columns. It would be possible to do, you could do something like for column and row. Pretty sure this will not give an error. But you never want to do that. Yes. Yeah.
I'm a little confused, like, so is it giving different things every time, or is it, like, so when you do row at 0, we said it was 1 and row at 1 is 12.
Mm-hmm.
Can we maybe go over how you got that again?
Sure. So the question is basically going over how this output correlates to what's down here, how the code up here correlates to what's down here. So for each one of these rows right here, what I put in square brackets is the index of the column that I want to print out. The column corresponds to this column list that comes after the select statement right here. So select these columns right here, select password and ID. And so because password comes in position 0, row at position 0 right now is going to be the password. So right now the position 0 right here, Trump. Position 1 right here is ID. Changing things over here, changing this will potentially change how many rows I get back. So we don't need a where clause at all. We could just do something like this. Select password ID from users, run that, and now we get all of the different users and their passwords. But the columns and their indexes still are the same. So up here, we get Trump, Biden, correct horse, battery, staple as the column 0, as the password column. If we come back to dbcreate.py and look at the first 3 accounts that were created, we see that Trump and Biden are these first 2 passwords, and then the correct horse, battery, staple password. So these 2 parts of the select statement affect how the stuff, like what is inside of these columns at position 0 and 1. What comes over here affects how many rows that we get, how many times this for loop is going to go through.
So if you put like ID and password, you get the ID first and then the password.
Yeah, great question. So yeah, the next logical question is, what if we change the order of these things up here? Do it something like ID, comma, password, save that, come down here, up arrow, rerun it. And now I've added this back in, so we're only getting a single row. And now our column order is first the ID. So row at position 0 is the ID, a number right here, the number 1. And then row at position 1 is the password, password up here, the password down here. If I tried to do something like print row at position 2, row of 2 like this position does not exist in this list up here. So we'll save this, come down here, rerun it, and you'll see that we get this, this out of range error because this 2 is not a valid index into this up here. If I wanted to make it a valid index, I could add another column up here, something like the username. And now we have access to the username as well down here. On the quiz, there's not going to be any error messages, but I might have any possible combination of columns over here to the left and I might have any possible like where clause over here to the right. So you'll have to understand, how does this where clause affect how many rows I'm going to get out, which rows I'm going to get out, and you'll have to understand how this column list affects which things are going to be printed out down here. Great question. Any other questions about any of this first problem? Again, the problem 1b.python is something, it has a different SQL statement up here. That's the only thing that I'll be changing is the SQL statement. And so you can check your understanding by doing problem 1b by yourself. Let's go to problem 2. And in problem 2, now we have two different SQL statements that are being run. The first SQL statement has an insert up here, and then the second SQL statement down here is a select. You'll notice that the format of what we're doing with this select down here is exactly the same as from problem number 1. That we have our selects. In this case, the select statement is getting out the same information, the same columns over here. And we're executing that SQL, then looping over it like this, and doing whatever our computation is with those columns. In this case, just printing them out. But we also now have this additional SQL statement up here, which has an insert that happens beforehand. Down here, it's looking for the username example. The SQL schema by itself does not contain the example. Inside of it does not contain an example user, but this insert line right here, this will create for us a new example user. It'll insert it into users, these two things, username, password, and then example, comma, password right there. It'll execute it. And this connection.commit, you will always want to have this line for any statement that modifies the database. You don't need it for the select statements, but you do need it for the insert or update or delete statements. Committing is SQL language, SQL terminology for just saving. So we've made a change to the database up here. And then committing it means actually save that to the database, like on your hard drive, on your computer. And then we'll come down here and do the select statements. For the purposes of the quiz, I'm always going to have the right Python code here. I'm always going to have this commit here. But if you forget this, you'll have potentially very confusing things happen on your web page. For the quiz, I will always have the commit, but it's very easy to forget. Very easy to forget on your own code that you think you're inserting, but you're not actually saving it, and so you don't actually see the message up here. Question, Henry?
Does it saves to the DB file? So if we run other files, like searching for things, the example password will continuously be on the DB file no matter what we do?
Yeah, so the question is, if this saves it to the file, does that mean that it's like going to be in the file forever? And the answer is yes. So I want to take a look at this here for a second. We'll save this, come down here. I'm going to use the SQLite command again, just to evaluate the contents of my Twitter clone.db, SQLite Twitter clone.db, and let's do a select star from users down here. And so we can see down here that Kristen is the last user. The last ID is 7. There is no example user. If you look through all of these, there is no example. Press Control D to get out of SQLite. And now I'm going to run the problem 2 code right here. Problem2.py. When I run this, it's going to, so first do this insert, and then it'll do this select down here. This select will find what was inserted up here, And so we'll see that our ID and our password will match the ID and the password that got introduced up here. So Python3 problem2.py. We now have a user ID of 8. Looking up here, we see that there was previously no user ID of 8, and we have a password of password because that's what I decided to specify right here. If I come down here into my SQLite 3 command again on twitterclone.db, and I rerun this select star from users, you'll see that this additional user has now been added to the database, and that is like a permanent addition, so that anybody who's working with this file in the future will still see that there. On your Twitter clone project, every time somebody posts a message to your Twitter, you will be inserting it into your database and then doing the commit. And so it'll be there forever, and you can stop your program, restart it, and all that information will still be there. Good questions. Any other questions so far? That got this output down here. So in order to get the output down here, I did that inside of SQLite 3. So you always do SQLite 3 and then the name of the database that you're connecting to, like that. And then the SQL command that I ran was select star from users like this, just to get all of the output from the table. If I wanted to, I could just find the output of the username like this, select star from users, where username equals example. And now I can just find out exactly like, did this information up here get inserted correctly? Is it example? Is it password? That looks good. And so you can run whatever SQL statements that you want down here. I'm going to modify this real quick. Actually, before we modify it, I'm going to rerun this command. So we've already run this command once. Let's see what happens when I rerun this command. Python3 problem2.py. So we already have an example user inside of our database. We've seen that in our output down here. We have an example user inside of our database. What happens if I try to insert another example user into our database? So Python3 problem2.py, and you see that I get this error message down here, this integrity error saying that this unique constraint failed, users username. This thing to the left is the table. This thing to the right is the column name. This doesn't, it already exists in our database. The database is structured so that you can't have multiple users with the same username. That would be bad if you had multiple users with the same username on your Twitter clone. And so if you try to do this insert and it already exists, then you're going to get an error. For the purposes of your quiz, you're not going to have to worry about these error messages at all. This is just something good to keep in mind while you're programming, that if you get this unique constraint failed, it means that you're trying to insert a user into your database that already exists in the database.
Say you accidentally entered in the wrong one, you just go like delete ID, password, code, square, like switch that out or delete, and then it will get rid of that line.
Yeah, so the question is, what if instead of like doing an insert, we wanted to do a delete or an update? You can put whatever SQL code you want inside of this this command up here, and it'll run it. Similarly, you can put any SQL code you want inside of down here, and you can run it. So I could do something like delete from users where username equals example, like that, and now select star from users, and now that that username is no longer down there.
And that's also.
The question is this a permanent change at this point? In order to make changes permanent inside of SQLite, there's this additional thing that you need right here, commit. So I'm not going to do that yet. I'm going to leave that, come out, rerun it, select star from users. Oh, I guess it automatically did the commit for me. So it is a permanent change. I take that back. Yeah, it's possible to have your SQLite settings so that it doesn't automatically do the commit. But I guess here it did. So now that that is deleted, I could come up here and rerun problem 2, getting the answers again. If I rerun it one more time, then I get this integrity error saying the unique constraint failed. For the purposes of your quiz and practicing for the quiz, every time you run one of these Python programs that has an insert into it, I think it's only problems 2 and 3 that have the inserts. Every time you do this, you'll want to just delete your python clone.db, delete that, and then rerun python3 dbcreate.py, get a very fresh new Twitter clone.db file, and then rerun your problem on the fresh file. The quiz itself, all the output will be assuming that you are running this on a freshly created file of this dbcreate.py. So I'll type that out in case you missed it. Do it up here at the top. For the quiz, always assume you are running on a freshly created Twitter clone.db. And so when practicing, you can delete the old Twitter clone.db file and rerun the dbcreate.py file to get this fresh Twitter clone.db file. Any questions on this problem 2? Okay, again, the problem 2b has more variations on this. The sorts of variations that you can expect are just me changing the SQL here so that I'm creating a new user or creating a message and then selecting something different from the users and message. I'm not going to change the Python code, only change the SQL. Problem 3, though, is where things start to get a little bit more interesting in that Python code and SQL can be changed. And the important thing here to recognize is that these SQL commands, this SQL command is just an ordinary Python string. There is nothing special about these SQL commands. And so we can use our ordinary Python string manipulation tools in order to construct these SQL commands for us. It's very common to, for example, get a username and a password from some external source, like somebody types it in on the internet, and now you have their username and password, and then you have to construct a SQL statement that is going to either create an account for them or check to see whether they're logged in correctly or not. Here, the way we're doing that is we're creating this SQL statement right here. And I'm using my just ordinary Python skills again to ensure that the very first thing that gets inserted is the username, and the very second thing that gets inserted is the password. I'm gonna not actually run any of this SQL code here. I'm just gonna put the word crash right here so that the program crashes at this point, and I want to print out what this SQL code actually looks like. Python 3, problem 3 like this. And so here, SQL equals this thing right here. We get this error message down here, name crash is not defined on line 14 right here. I just added that so we don't actually run the SQL, just so that we can look at only this line by itself. When you're working on your project and the lab this week, you're going to have to construct your own SQL statements like this programmatically inside of Python. And the way to ensure that the SQL that you're getting is reasonable, is what you want it to be, is to print it out like this. Print out the SQL before you actually run it, and then you can take a look at it like this and see, oh yes, this actually looks like the SQL code that I wanted it to do. On the quiz, you're not going to have any typos in the SQL code, but a very common source of typos is there are so many like quotation marks going on here. Very easy to get confused on those quotation marks. I get confused on those quotation marks when I'm working on this side of stuff. So I always print out the SQL code down here, visually inspect it, and then once I'm confident that it looks good visually, then I actually run it. Excellent.
Why do you have all those extra quotation marks?
Question is, what exactly are all these extra quotation marks doing? So let's compare first to problem2.py, the same insert statement. You'll notice that this SQL code right here exactly matches this SQL code right here. And I have the triple quotation marks right here because it's a multi-line string. And in Python, to make a multi-line string, you have to use the triple quotations instead of single quotations. I'm using the triple double quote instead of the triple single quote because over here, I'm using single quotation marks. SQL forces you to use single quotation marks to denote strings. And so if I were to do something like this, then Python would get confused because it says, okay, you're starting the string here and you're stopping the string here, but that's not what we want. We want this to be part of the string. And so I need to, I could use double quotation marks like that. Now this is actually part of the string right here. But it's just sort of traditional, at least something that I like to do to make my SQL code more readable is to put it on its own line where there's no Python on the same line as the SQL. And so in order to do that, I need to have the multi-line strings like this. And then so over here on problem 3, what's going on is that these multi-line strings are the same multi-line strings as problem 2 right here. But then we have the single quotation marks right here. We have to enclose this inside of single quotation marks. So over here in problem 3, we have these two single quotation marks, which ensures that whatever gets substituted right here is going to be inside of single quotation marks down here for the SQL code.
The triple ones used to denote that the SQL is ended and there's Python there and then it goes back to SQL again.
Exactly. This triple right here says that we're no longer inside of the string, no longer creating SQL code. Now we're writing Python right here. Python will interpret this for us right here, do the Python string addition right here, and then back inside of normal strings right here, creating the SQL code, back inside of Python right here. VS Code, you'll know that you can just use sort of like the syntax coloring to keep you in check that the stuff in white is not SQL, it is Python. Only the stuff in orange is SQL. Good.
I keep getting the error message that says operational error no such table.
Yeah, okay, great. Question. Let's pause our problem 3 right here. This is an error message related to what's going on problem 2. I'm going to rerun problem 2 for a second. And so we get this integrity error. We said the way to solve this integrity error is to delete your twitterclone.db file. Every time you're running a program, anytime you're running one of these problems that contains an insert, you want to be running it on a fresh twitterclone.db file. The way to get the fresh twitterclone.db file is to delete the old twitterclone.db file and then rerun the dbcreate.py file. Let's see what happens though if I forget this step. If I forget that step and just rerun this right here, we get this operational error, no such table users. Here on this line, SQLite doesn't care if a database exists or not already. If it doesn't exist, if the DB doesn't exist, it will be created automatically. So that's what SQLite just did for us. It created this twitterclone.db right here. I'll delete that again, move it to the trash over here, up arrow, rerun it. And it created this twitterclone.db file right here, created this twitterclone.db file. But it didn't actually insert anything into it. And so I get this operational error, no such table users. We can't insert into users if we haven't run the create table command. So anytime you get this operational error, no such table, operational error, no such table, that means that you forgot to run the db create. So we get this no such table users. Let's run the db create down here. So python3 db create.py. Rerun my problem 2 now, and now I don't get that error message. Great question. Yeah, so again, I think the hard part of this, these last 2 weeks of the course is that, like, just, I know individually all the concepts are more or less things that we've covered so far in this class, but there's just a lot of like ways that things can go wrong. We're using a lot of different programming languages, connecting them all together, figuring out like what is the actual root cause of any particular error that you're getting. Very hard to do. Okay, so this insert statement right up here is the exact same insert statement that we had on problem 2. So in order to, again, run this, delete the twitterclone.db, recreate the twitterclone.db, and now problem 3 like this, run it, and we get the same output as problem 2. The only difference between problem 3 and problem 2 is that right here in this SQL statement, I am constructing this SQL statement using Python. That is the only difference. Any questions on this problem 3? Yes.
So, sorry, just to clarify, where does operational error get from? Like on which line?
Good question. So let's redo it with problem 3 here. Let's up arrow rerun problem 3. We get the integrity error. So we'll start with the integrity error happening here on line 13 with this execute. The integrity error is happening because we're inserting into users, and we already have inserted this username into users. So I'm going to delete the twitterclone.db file, delete that, come down here, up arrow, rerun this program, and now we get this operational error also on this same line 13 right here, on this cursor.execute line. We get the operational error on this cursor.execute line, no such table users. Because I deleted the table, but I forgot to recreate it. Now I run the dbcreate.py file like that. Now the twitterclone.db exists and has been, say it's populated with values inside of it. And so now when I run the problem 3, no problems. Question?
So with the integrity, you said that happens when you're inserting a user into.
When you're inserting a username that's a duplicate that already exists. Let's see, since we're talking about error messages right now, let's look at one last possible error message with SQL that you'll definitely encounter at some point. Let's see what happens if I forget to include these quotation marks over here. So we were talking about these quotation marks earlier. I don't include these single quotation marks. Why is that a bad thing, or what bad thing could happen? I'm going to re-add my printing out the SQL statement right here so that we can see what the corresponding SQL is going to be, and we'll rerun this code. Up arrow, rerun it, and I get another operational error, but this is a different operational error than we had before. Again, the operational error is always happening on line 14. So this execute line, anytime you're getting an error somehow related to SQL, it's going to happen on the cursor.execute line. Anytime you get an error from SQLite 3, it will be on this line. So wherever you're calling cursor.execute, and that means that somehow the SQL variable is not created correctly. Means the SQL variable not created correctly. And so if the SQL variable is not created correctly, then you have to come up into the spot where you're looking at the SQL, creating the SQL, and figure out why is it not created correctly. And over here, it's because we can actually visually inspect now this, this result down here, and it's because there's no quotation marks around this example. If we change this code even more, something like, say we forgot, have a typo here, we just have va instead of values, rerun this, operational error, near VA, syntax error, near VA, syntax error. Actually, like, I don't know, these SQL doesn't give particularly good error messages. You might not like Python's error messages, but they're way, way better than the SQL error messages that you get here. But anytime you get these errors, it means that the actual error is not in your Python, it's in your SQL, and you have to figure out what's wrong with the SQL. Okay, problem number 4. So creating these SQL statements can be a pain sometimes. And so Python SQLite does have a nice feature built in that allows you to not have to create them manually all the time. And this is this question mark feature like this, question mark, question mark. Notice that this question mark is not inside of quotation marks. It is just sitting there all by itself. And now I've changed this execute call to the execute command down here on line 13 so that I'm passing in a list over here of Python values. The first one is username and the second one is password. Each one of these question marks will get substituted with these usernames and passwords down here. So this username corresponds to this username variable. This password corresponds to this password variable. And we'll insert them on this command right here. The execute right here, again, substituting username in for this question mark, password in for this question mark here. I'm going to go ahead and run this. Let's delete our Twitter clone.db, up arrow, and let's, we need the db create, db_create.py. And now run problem 4. And we get the same results that we had from problem 2 and 3. That the only difference between problem 2, 3, and 4 is I'm using 3 different ways to get this insert statement to be constructed. In problem 2, I'm just hard coding everything directly into the SQL here. In problem 3, I am using Python normal string manipulation to construct the SQL using Python. And then in problem 4 over here, I'm using this special question mark notation and adding this extra list down here to substitute for the question marks.
Could you put a question mark like anywhere in the SQL code?
Question is, can you put a question mark anywhere in the SQL code? And the answer is no. There's very specific rules about where you can and can't. For the insert statement, it has to be inside of these things over here, the actual values that you're inserting, and it corresponds to just a single column. So this technique over here is more general than this technique over here, but this technique over here is maybe a little bit easier to use and understand. Again, what possible error messages could we expect from this? What happens if I don't have my password that I'm putting in here? So here I only have 1 element in this list now, but I have 2 question marks over here. I rerun this and I get this programming error, incorrect number of bindings supplied. This question mark and this together are called the bindings. So here we only have 1 of these values for the question marks. And so I get this incorrect number of bindings supplied. Programming error, incorrect number of bindings supplied, caused by too many or too few elements in the list. So here, username, let's add password back in. Let's just add in a 1 over here, run that again. Oops, normal Python error message there. Mistyped password down here, up arrow, rerun it, and still getting this incorrect number of bindings supplied because now we have too many. Save it like that. And now we're not going to get the bindings error. We're going to get back to our integrity error, the unique constraint violated. And so if I delete this Twitter clone, move it to the trash, come over here, rerun my Python 3 db create command like that, then I can rerun the problem 4 like that, and everything works. Again, the question mark just means that it is doing the substitution here, and the question mark has to be outside of quotation marks. If the question mark was inside of quotation marks, this would be the string quotation mark and not do a substitution. One last problem for us today, problem number 5 over here. This is different than problems number 2, 3, and 4. 2, 3, and 4 were sort of all variations on this same theme. Problem 5 is back to only using select statements, no inserts. But what problem 5 is evaluating you on is the ability to combine information from 2 different tables. So up here, we're getting information from the users table, and then down here, we're getting information from the messages table. The main reason why you want to do this, and you'll have to do this in your project and labs, is that the messages table does not contain the actual username of the user who sent the message. If we come back over to the messages table over here, where we're creating the messages table, you can see there is no username inside of the messages table of who sent it. Instead, there's a sender ID, an integer of who sent it. And so in order to get the actual username, you have to come up here and look inside of the users table for the corresponding ID to get the username. That's what problem number 5 is doing, is it's combining information from the 2 tables together, matching the ID from the username with the messages from sender ID. So here, this is the same exact SQL select statement that we've been using before. I'm now just username, making it this binding right here equals question mark. We'll search for username Mike and get the row out. This will get my row out and put it inside of this user IDs right here. I'm going to go ahead and just add a crash right here and a little print user IDs equals user IDs like that. Come down here, up arrow, rerun that. So there's our crash. Here's the user ID 6, which is the user ID of the Mike user. Again, the Mike being substituted in for this question mark over here. And comment that out. Now I'm going to loop over whatever user IDs I get back. The way this is currently structured, I have to get back exactly 1, but I could change this statement, something like this. Again, this is a SQL comment, so it's not going to evaluate this, only going to evaluate this over here. And now this will get me back all of the user IDs, and so I might be looping over multiple user IDs, depending on exactly what this SQL statement looks like. And for that SQL statement down here, I'm going to count the number of messages sent by that particular user ID. Sender ID over here equals question mark. And substituting in the user ID for this question mark, we will get the number of messages sent by that particular user. If I come down here, rerun problem 5, we'll see that the user Mike up here, we got the user ID for Mike, substituted it in over here. So we're counting the number of messages sent by the username Mike. The answer is 3. If I change this up here instead to be, say, Trump, save that and rerun it, Trump has only sent 1 message. If I change this to be something that doesn't exist, some gibberish like that, come down here, up arrow, rerun it, then there's no output at all. A lot of, 100% okay if you don't fully understand all of the code that we've seen today. There's a lot of different moving parts, and definitely takes practice working through these different problems and to get a hang of it. That's the stuff for the quiz for next week. Last quiz of the class, and that's the end of our material for today.